welcome everyone. This is the webinar on 5G and satellite, driving forward the network of networks. This is part of the series of webinars organized by the GVF in collaboration with Satellite Evolution. And the event is kindly sponsored by Spacebridge. So I'm delighted to have been asked by GVF to moderate this session. My name is Mauro Cordani. I'm from the European Space Agency, and I'm part of the 5G strategic program in the telecommunications division. We promote the use of satellites and space-based applications for interesting and innovative use cases, just like 5G. I'm very pleased to be joined by a very capable and interesting group of panelists who I'll now introduce. Firstly, we have Amy Chan from NORSAT. Amy has over 15 years of experience in executive management and research and development in the telecommunications industry. Amy was appointed as CEO of NORSAT in 2006. In 2012, she won a Women's Executive Network Award and led NORSAT to win a British Columbia Export Award. Dr. Chan holds an executive MBA from Simon Fraser University and a PhD in satellite communications from the University of British Columbia. Next, we have Scott Mumford from Liquid Telecom. Scott has over 23 years of experience in the satellite industry, including time at Williams, Global Access, Kingston, which later became Arqiva. He has extensive experience in teleport network engineering, all the way through to commercial solution design. He's now the CEO of Liquid Telecom Satellite Services, which is a division within Liquid Telecom Group. And Liquid Telecom are the largest independent voice and data supplier across the African continent. So Michele Di Paolo, who I believe goes by Mike, from Spacebridge. Mike has responsibility for promoting Spacebridge's solutions to end users and system integrators around the world. Mike is a telecom specialist and advanced technology expert with over 30 years of international sales, customer support, business development, and project management experience in sectors ranging from military to telecom to VSAT. For the past 15 years, Mike has been an evangelist for cellular backhaul, promoting and influencing mobile operators around the world with regards to 2G, 3G, 4G RAN backhaul. Mike holds a bachelor's degree in computer engineering from Concordia University in Montreal. So a great panel, very different perspectives. It'll be interesting to hear their views on the topic. So welcome. 5G, not just another G, as somebody once said. It's truly a system architecture, a new system architecture enabling global connectivity. 5G globally connected world of devices and consumers will require wholesale integration of satellite with the terrestrial network to benefit from some of the features of satellite. So this session will explore the various facets of this enabling environment, including the engineering challenges and technical and business strategies needed to underpin the deployment of a truly ubiquitous network of networks. And audience, please feel free to submit your questions via the Q&A. I will not be picking up questions from the chat, so make sure you submit them in the Q&A tab. But we will start with some prepared questions for the panelists. So first question, the 5G standard now seems fully transparent as a new networking architecture with multiple access technologies such as Wi-Fi, small cells, mobile, wireless, satellite. My question is the satellite industry entirely clear on where it stands or as a partner in respect to this transition? Mike, maybe you'd like to kick it off.
Sure. Thank you very much again to the GVF for hosting this. It's a great event. With regards to this question, I think the satellite industry has a great idea of where it wants to be. Okay, not necessarily reflected in the standards. Okay, the standards are, of course, a global, are reaching to define where we could actually play in this industry, whereas there's so much innovation in the satellite industry that it's hard to actually pinpoint it as to where you want to go. So for example, there's parts of standards which deal with how the satellites can connect directly into the 5G environment. And then there's and as a ground equipment vendor, I don't actually play into that. But as a ground equipment vendor, I actually have to have a role in how ground equipment can connect over existing satellite or even future satellite to be part of this future 5G partnership. We envision that, you know, in terms of 5G, the existing role of cellular backhaul will continue to be a mainstay, but we also see innovations that will be driving 5G core technologies into VSAT terminals and IoT devices over satellite in order to deliver a more communal 5G network of network per se. So we believe in that satellite as a service will become part of 5G. We believe in that there's a lot of different innovations that are going to take place. And we're looking for those catalysts, which will basically launch 5G over satellite. I'd like to make a point over here that 4G over satellite has been incredibly successful. And it is the direct result of three catalysts, okay? The three catalysts being that the introduction of HTS satellite, providing incredible amounts of bandwidth, in the introduction of satellite modems, powerful enough to take advantage of those things. And the third thing was actually the 4G technology itself being satellite friendly, and the updating of operating systems to allow high throughput, even in high delay links. So I think that if we find those same we find the catalyst which will drive the 5G, it'll be as successful as 4G has been so far.
Okay. All right. Thank you, Mike. So with regard to satellite, what are the particular and unique characteristics of satellite that make it so essential for realizing the full potential of 5G? Maybe Scott, perhaps you'd like to take this one.
Yeah, absolutely. Thanks. Look, I think satellite has a capability that very few, if any, other telecoms media have, and that's that ability to be able to cover large areas of landmass with capacity that can dynamically move around to where it's needed at any point. I think that in order to fully take advantage of that, us as an industry and the MNOs as a whole rolling out the 5G infrastructure have to look at that and go, okay, you know, how can we overlay that demand, you know, with the infrastructure that we're putting into the back end of that to make sure that the connectivity is there when it's required. And I think satellite's the only medium that's capable of doing that. Now, is that going to be the answer to all of the connectivity to the 5G base stations? No. Obviously, Liquid as a company are doing a lot around the fiber optic side and the high-speed links into the base stations from the fiber network. But, you know, as an operator capable of delivering both, being able to put in solutions that enable you to boost that bandwidth on demand using satellite across a number of base stations, and being able to roll that out to rural locations where perhaps the demand isn't necessarily as high, is a real USP to both satellite as a technology and us as a service provider as a whole.
So the ubiquity, I guess, the coverage, but you also just mentioned something very interesting, the bandwidth on demand. Maybe you might want to elaborate on that just for a second, Scott.
Yeah, absolutely. And I think as Mike was saying, you know, the advent of HTS satellites has really transformed the bandwidth capabilities in terms of what we can put into a single terminal. You know, the slight downside to that is obviously the slightly more reduced geographical coverage of specific beams. But you know, if we look at, and I won't mention specific platforms, but some of the technologies that have come out now that, you know, basically offer dynamic SCPC capabilities to be able to put in really high-speed two-way satellite links to anywhere within that footprint at any time. You know, it's a massive cost reduction to be able to suddenly put in another 100-200 megabits per second to a base station without having to physically go and dig a fiber cable 30, 40, 50 kilometers between an access pop and that base station. You know, and as I mentioned, that boost capacity in terms of being able to put in satellite links to base stations that are connected via fiber that may suddenly see an increase in traffic due to specific events or emergency services, to be able to provide that on demand, really just set satellite alert, apart from any of the other media that connect these space stations.
So bearing in mind, I guess the 5G rollouts in different parts of the world will be at different rates, and operators, obviously cautious about managing rollout expectations, especially in the light of the current economic climate. What major opportunities, I'm going to address this to all three of you, what major potential opportunities does your company foresee in the 5G satellite communications market over the next decade? Maybe Amy, you could start off.
Yeah, that's a really good question, Mark. From Norsat's point of view, we're a ground terminals equipment provider. What we see is actually over the next 18 months to 3 years, there's going to be a lot of terminals that are going to need retrofit, or what we call upgrading, so that they could be 5G ready. And so a lot of these terminals building needing filters, new LNBs, maybe some new antennas and modems. But what we see is some of these terminals may even need, they're so close to the 5G station that they can't operate in C-band, and they're going to need to go to KU or KA. So we see a huge demand for this. There are probably over 200,000 terminals that are in C-band right now that will need these upgrades or transition to another band. And so we see this huge opportunity, but it's only really 18 months to 3 years, because after that, 5G is all rolled out. We don't see that same rate of upgrade.
Okay. Interesting. So maybe from a technology or equipment provider, Mike, what do you see?
We've read in numerous reports, and the expectation is that there's approximately 80,000 new base stations, which are going to be deployed over VSAT in the next 9 years to facilitate and support further 4G and 5G rollouts. Business cases have been presented, supporting both small cell and macro cell deployments on the purely backhaul market view. And while small cells make up a large part of the deployments, but a very small part of the bandwidth, while macro cells make up a larger percentage of the bandwidth, but fewer sites. So you need a technology, as Scott mentioned, which provides a bandwidth on demand, and it has a variable capacity. So for small cell deployments on the SpaceBridge side, we offer an MFTDMA solution, which is very cost competitive and performance competitive, and we can support all of those. And then in a dynamic manner, as for macro sites, we could actually support bandwidth on demand SCPC as well, to provide that higher spectral efficiency and higher quality of service. So we can provide that service as well. And so we feel that our positioning right now is very well suited to this 80,000 new base station deployments. So now there's other opportunities, of course, which are very interesting. There's a video offloading, there's caching, there's a number of offerings, hybrid networks, and in each of these things, our hub capacity can actually support that. We have built-in compute capacity to support different type of offerings. We're actually very optimistic that these solutions will come to fruition. At the end of the day, it'll all depend on the commercial offering and the commercial limitations of the mobile operators, of course. But we're ready to go for the next 10 years with what we believe what we have in stock, or what we have as a solution. Or rather, we can manipulate our solution to meet what will be required for the next 10 years.
Great. And Scott, where do you see the opportunities for satellite communication in 5G next 10 years?
I think obviously I agree with both Amy and Michael around their views, but I think operating where we do, specifically in Africa, we see that deployment as obviously as a leapfrog opportunity, really, from a technology standpoint. If we look at where the MNOs are and the smartphone penetration rates into Africa, you look at the potential cost difference between rolling out 5G infrastructure and rolling out 4G infrastructure. and where that's actually been deployed within the major African country metropolitans at this point, I think we're actually going to see a bit of a leapfrog and a lot of the MNOs moving straight towards 5G deployments. Now, obviously, as we're seeing that smartphone penetration increase and the demand go up, the time frame to be able to get all of these base stations from a network rollout online is going to be critical. And I think that's really where satellite comes in, because of the speed of and ability to be able to deploy anywhere within a given country, and get the base station online and that bandwidth in there quickly. I think as a service provider, and from the fiber optic side of our business as well, it's a real proving ground to see where that demand is in terms of the cost analysis to be able to dig fiber into these locations, to be able to provide the higher bandwidths into those base stations. So I think as a business, we have to look at all of the technology available, look at all of the options that are available, and make sure that we're not only providing access via all of them, but also using them to see where our best economies of scale come from, to be able to deploy the infrastructure across such a huge geographical landscape.
It must be an interesting trade-off, I guess. Yeah, maybe we'll get into that a little bit more in a second. But I actually have a question from the audience, related to the same discussion, from Richard at Walton. He's asking about where do you see the opportunities for teleports with 5G? I don't know. Any of you want to jump in? Specifically for teleports. You see it business growing, or what? Wants to sell more DI systems.
Yeah. I think with teleports, there's definitely going to be a need to retrofit for making sure that they have the right equipment in place. But I think with the teleports, it also can actually take a look at to see what additional capabilities they can add in. So to augment the C-band offering, do they need to make sure that there's Ku-band and Ka-band? And at the same time, to make sure that their current C-band customers are not impacted, reaching out to their current install base, figuring out where they are relative to the 5G rollout, and making sure that when 5G gets turned on, they're not impacted. Because I think there's still a lot of people out there that are going, oh, well, when it comes, and it gets wiped out because the 5G signal is so much stronger than the satellite signal.
Mm-hmm. Okay.
Amy has made a great point on the spectrum side, and on the equipment side and ground equipment side and the services side. I think you see a lot of the teleports now touting their cloud capabilities as they move cloud and high-speed capabilities into the teleport. I think that's essential for them if they want to provide a more ubiquitous service for the 5G. The provisioning of services, the closer you are, the better you are, is true when it comes to especially to 5G. And pushing cloud into the teleport is one way of looking at it. Or there's discussions that go the opposite, which is pushing all the intelligence out of the teleport into the cloud. So it may be one or the other, but it's hard to decide now which way it'll actually go in the long run.
Yeah, it'll be an interesting discussion. For sure, it's inevitable. I think there'll be more edge computing at the teleport, as you say, Mike. But how much things become virtualized as we go forward, who knows? Let's push on. I've got another question from the audience. This is from Michael DeConick. How does satellite 5G fit into the 3GPP release 15/16? Anybody want to take that one?
Boy, I have to look up my my data, but what I've read up on the different offerings from the 3GPP, as I mentioned, was that there's a lot of work that's being done on the satellite operator side. Okay, that is, I think, where a majority of the work, because of the ideas of combining satellite and 5G together, like offering offload services and such stuff, or direct to handset connectivity from satellite. These are really, really great works. Whether they'll come into fruition, somebody has to invest the money. Okay, so there's that. On the other side, there is, of course, as the way I like to see it is that there's more of the 5G core technologies being rolled into satellite in the sense of like for one of the things that we're working on over here, for example, is potentially putting eSIMs into our VSAT terminals and allowing it to be directly managed from a core service across the VSAT. So VSAT will be transparent, but the orchestration will be at the 5G level. And so these are the kind of things that we're looking for, not necessarily falling exactly into the standards, but our own deviations of them.
Yeah. Anybody else want to add to that? Or I do know, I know that the satellite industry is certainly participating in 3GPP. I'm certainly not the expert. I think the important one from the satellite community point of view is really 17. That's where they've been called non-terrestrial networks, NTNs, are specified. So I think release 17 is the big one for us. And the good news is, I guess, that satellite is included in those 3GPP specs, at least as far as I'm aware. Okay, enough on standards. Next question, maybe, if I can. I think this is kind of the heart of this whole topic. So going forward, satellite will no longer be a separate standalone network with just interfaces into the wireless systems, but it'll be integral to an evolving network of networks or system of systems. It certainly will become a standard radio interface within the multi-radio network architecture of 5G. But how much more is there to this? Could you elaborate? Maybe Scott?
Yeah, I think we're already seeing that migration really into a network service, irrespective of the technology that's providing the overlay and connectivity side of that. You know, like I say, as a terrestrial and satellite service provider at the moment, we've got a number of customers who are taking services on both media, but as a single network supply. Now, that's really down to the service providers as to how they tie that into their SLA and how they manage that as a cost-based scenario. But I think, you know, as we've seen prices for satellite connectivity and ease of terminal installation and terminal prices come down, I think that's going to become more and more the case, that actually, you know, giving you that diversity from different technologies, but with a single network supplier, is going to become much more apparent. I also think, you know, as generally all of us move much more towards a service orientated use of data, you know, whether that be content or whether that be, you know, the applications that we use, you know, the technology that provides the underlying connectivity element of that becomes less important to a large degree, which, you know, I find hard to say as a satellite service provider, but that's the reality of it. You know, we all really want the applications on our devices to work wherever we are. Now, the service providers as a whole really have to look at that, you know, and decide whether that's ubiquitous coverage and connectivity via whatever mechanism they choose to use is a cost that they're prepared to pay. But ultimately, I think they're going to have to move down that road, because the demands and the reliance on you know, handheld devices and applications is so high now that you know, if you're not leveraging it, you're really missing out.
Interesting, that, you know, service perspective. I think you're absolutely right. Mike, do you want to add to that? I mean, I think from your point of view.
One of the things that I find interesting, and you see it, Scott was mentioning, you see it across the board from the satellite operator perspective, and you see it on the ground equipment vendor perspective, is that these interfaces, the traditional proprietary connectivity offered by a VSAT solution is probably just not good enough anymore. There's a whole scale move by the industry, be it the satellite operators, such as you know, mPOWER is an example of such a thing, with the way that they're planning on doing their SD-WANs and Metro Ethernet capability and orchestration. All these things that fit more comfortably into the existing terrestrial network versus offering a proprietary or orchestration solution over satellite. So I think that there's a lot of work going on from the satellite operators, SES, Telesat, with their LEO proposals, and Intelsat with their own offerings. On the ground equipment side, there's the same level of efforts that are going on to facilitate the orchestration of the services that run over satellite in a more common manner to allow tighter integration with the terrestrial networks. So there's a lot of effort going on that side. And I think that that's going to be a big differentiator moving forward. I think you're going to see some interesting solutions coming forward in the next number of years.
Yeah, I agree. I think you're right. I think you mentioned orchestration there. I think certainly in terms of provisioning of bandwidth, getting one bill for your services. I mean, I think those types of integrations are, I think, what consumers and businesses are really looking for. And as you said,
Scott was
they
mentioning,
don't care how that service is delivered as long as they get what they need. I think that's the type of integration we're talking about here.
Yeah.
Very interesting. Maybe we can come back to that. But Amy, I've got a specific question for you regarding spectrum, and I think you mentioned interference. So, what are the technical engineering initiatives that you're developing or bringing to market to prevent that signal interference and disruption from the 5G base stations? Again, we're talking specifically about C-band ground terminals. So what are some of the challenges and pitfalls that you see to transitioning current C-band terminals to make them 5G ready?
So I think where we see the biggest problem is actually in the hardware. So usually when you have a terminal that's very close to a 5G station, and by close, anything that's within 200 meters is actually what we call near field. And so we see a lot of 1.8 meter dishes, 2.4 that are actually within this near field of a 5G station. And even if they're not in the near field, there is going to be definitely a very strong signal if you're pointing to, in that direction of a 5G base station, where that will actually either saturate your system or it'll cause intermods. So most people worry about saturation. They go, yeah, I'm going to put a really, really big filter in front of my LNB. It should be all good. And so, yes, I think for most terminals that may work, but for a lot of terminals, what we see is even with that filter, is actually the 5G signal is still getting in at a certain level into the LNB. And because the LNB has gain, it actually saturates maybe something a little further downstream, either a mixer or another stage or even the modem. And it could be saturation or it could be intermods, because this 5G signal is actually going to mix in with the satellite signal and cause a bit error rate problems. So we're coming with innovations where it's a filter combination with special LNBs with built-in filtering and more robust, what we call immunization against 5G. And the combination has been very, very successful in some of the 5G rollouts we see, like, for example, in Korea, in China, and the rest of the world that's a little bit, have started their 5G rollout a little bit earlier than North America and Europe.
Yeah. So I guess spectrum is precious. So maybe staying with you, Amy, maybe at a general level, what do you see as being some of the other key innovations that can help the current C-band operators with this transition?
So I think there's a few things. So C-band operators that are going to be staying in C-band, they've got to get their terminals ready in terms of their filters and LNB. And then you've got guys that are actually moving to Ka band or Ku band, and they have to worry about rain phase issues. So one of the things that we see that is a lot of people are using C-band because you get the great rain, even with the rain, you don't get the steep fades like Ku and Ka. In Ka band, your rain phase can cause you a 10 dB, in excess of 10 dB degradation. And so we're asking people, if you are going to you're in a rain phase region, you can actually you should have the biggest dish you can get, because I think you need to plan for it in your link budget, that these rain fades are going to be a lot steeper to avoid outages. And then the other thing that we see is actually with 5G is for guys that are wanting C-band, there are a lot of opportunities, particular, maybe even for teleports out there, where there's 5G, 5G is taking part of C-band, but there's still that C-band capacity. That satellite bird is still in the sky, and it's still operating in C-band for probably the next few years. And how do we reuse that capacity? So like that airtime is very, very precious. As you say, spectrum is it is a very precious commodity. If there's a way for us to use it, for example, if you're in a remote place where 5G is not coming for a while, that's an excellent opportunity to resell a C-band opportunity. Also, if you're on an island that may not have a 5G rollout yet, there's a way to, if you can continue using that C-band, that would be great. And also what we see is maritime operators. When you're close to land, you basically got the 5G interference, but you're out at open sea, you should be able to use that spare C-band capacity that's still out there. So here are some of the opportunities.
Yeah, we actually have a couple of questions in the audience, I guess picking up on that same topic. I think you've already answered one, Amy. Jean is asking, for the stations that move from C-band to KU-KA, can their service be improved? For example, rain fade. I think you've addressed that. Sound like you were saying stick with C-band if you can in the high rain fade areas. But so that's an interesting question that just came in. I don't know if you want to add anything more to Jean.
Yeah, so that's a really good question, Jean. A lot of people are in the equatorial region where they're using C-band. If you can find a way to stick with C-band, and so there's C-band where there's still a little bit of spectrum left from 5G, and you can keep maintaining that space, that would be great. Second piece is there's C-band INSAT, where it's a little bit higher C-band, but it's not quite KU and KA. And then if you absolutely have to move to KU and KA, I think there's low KU as one of your choices. And then also, if you do have to absolutely go to KA, everybody goes, wow, you know, I get this really tiny dish. And you go from if you have room for a 1.8 meter dish and you're thinking you're gonna go to a 75 centimeter, 75 centimeter may not be as robust, or if you don't have the power in your buck, you may actually have to make sure that you plan and design in your link budget for a bigger rain fade margin. I think it all comes down to design and where your what region you're operating and what is the rain fade criteria.
Yeah, exactly. I think there was another question there about KA band, and again, he's making that same point. You need to make sure you engineer your link budget correctly. I think he's having some issues in KA band. So yeah, I think it comes down to that link budget. So you're absolutely right.
I think that fundamental for the satellite industry as a whole is one that we've all we've all seen over the years, that the importance of actually doing the link budgets correctly and designing your network to run at the availability levels you need it to run is an absolutely critical element for any satellite service provider anywhere. Some of the nice toys that have been added to the product portfolios over the last few years, sort of ACM and the S2 standard and so forth, and the MFTDMA in terms of being able to adjust your modulation and coding rates to give you that higher availability. It's critical that you tune those to work for the region that you're operating in, rather than leaving them pre-configured as they come from the hardware manufacturers. So we're running a number of platforms, and we're operating in varying climatic areas across Africa, and we've fine-tuned all of the ACM switching points and the TDMA switching points for each of those to be able to get your availability. So I think that engineering and technical, I suppose not bespoke, but the configuration of how you operate those networks is going to become more and more critical around that as you're having to switch to the higher frequency bands.
Absolutely. Let's come back to some of the major use cases again, and I'm going to quote some of the 5G gobbledygook for a second. So we talk about enhanced mobile broadband, ultra reliable, low latency communications, massive machine type communications. My question to you is, where do you see satellite's critical role in each of these? Maybe give us some real world examples of specific applications where you think satellite is a good fit, and how does that benefit the end users and customers? Mike, you want to give it a shot?
Actually, I would like to hear from Scott first, if you don't mind.
Okay, as a service provider, good call.
He's actually an operator, so I'd like to hear from his perspective first.
Some
If that's okay.
what can you sell your customers?
Thanks for that, Mike.
I was going to ask him as well, but we'll ask both of you.
No. Look, as I said earlier, you know, satellites' inherent capability to be able to cover everywhere, you know, from a coverage perspective, is a really critical element of that. You know, the IoT boom is really still in its infancy, and although it's something we've all been talking about for a lot of years, you know, I still don't think we've got to the point where we're starting to see the level of sensor and node deployments globally that we're going to see over the next 5 to 10 years. You know, that ties into some very specific industries from a satellite perspective. You know, cargo tracking, agriculture, fisheries, and a number of other ones that it's very hard to connect those devices to, you know, specific networks, either via APNs or, you know, WiMAX or Wi-Fi. You know, as a company, we've provided some of these sensors in Kenya to agriculturals and fisheries already that are doing stock management and soil acidity and moisture level sensing and
Interesting.
I think that's really going to continue to grow, and the more you can tie in that IoT connectivity capability to the AI side of what the cloud offers in terms of farming, I think we're going to see a lot more intelligent farming, and a lot more on the automation side in the mining industry around optimization for truck moving and, you know, mine extraction and mine processing. So I think we're still really as I said, in the infancy of the deployments around these. You know, there's some really cool new providers coming into that market on the sort of nano sat and small sat markets, as well as the sort of bigger LEO fleets that are obviously going to be able to provide that sort of connectivity as well. But I think it's a really exciting and interesting element that the satellite industry is going to add a great deal to over the next few years.
Yeah, certainly some of that data does have high value. Sure. Mike, do you want to give it a shot, or did you punt?
It's a tricky question. I always find this to be a little bit of an uncomfortable question, because when you look at the different technologies that we're looking at, the question is always, how are you going to handle this over geo? And it's like a enhanced mobile broadband, okay, which is a technology which brings essentially those millimeter wave spectrums to 5G. Now, these typically have ranges of 100 meters, 100, 200 meters. Is there really a need to drive that over satellite? I always question these type of things. I agree with Scott with regards to IoT. I think that the work being done on IoT is phenomenal. I've personally participated and been part of the Connected Farm, and I've seen the big advantages that provides. And even though at that point it was an NB IoT provided over a 4G service, but just seeing those simple examples has convinced me that these are going to be like big issues over satellite as well. The ultra reliable and low latency communication, well, let's admit, these are all things that come when the 5G core will be deployed. Okay, they're only available on the 5G core. They're not part of, like, 5G as a radio interface will perform well. But these other services like ultra reliability and low latency, massive machine communications, IoT, these are things that require a 5G core locally connected in order to really take advantage of them. And I'm not quite sure at this point how that'll play in satellite, other than, of course, providing a backhaul function, providing or hybrid networks, providing a drop-off function, or those type of things. So I always find it to be a little bit of a tricky question, because I don't really see how that much of that industry will be affected by satellite at this point. Sorry.
Another question for Amy, coming back to spectrum just for a second. Could you say something about spectrum sharing, perhaps? Is there a way to share spectrum effectively between satellite and terrestrial in the 5G era? I mean, not even specific on C-band, but just generically, what are your thoughts on that? Because there's, I think, lots of challenges right now where you know, traditionally we've had separate spectrum for satellite and terrestrial, but now they're beginning to blur a little bit. What are your thoughts?
I think the key word is coordination. So right now, you know, you've got a C-band that is being shared between satellite as well as 5G. And 5G is, unfortunately, we say it's like a big hungry beast, right? It's very, it loves bandwidth. It's very, very high power, and it's everywhere, right? You're going to have small cells that are going to be closer together, and it's very likely that your satellite terminal will be, if you don't have the right equipment in there, it could be flooded with this 5G signal. So where we see spectrum sharing is, well, in places where 5G rollout is going to be further down the road, there's definitely an opportunity to reuse C-band in the current frequencies. So as I mentioned, if you're doing like communications on the move, whether you're on a plane, the C-band's unlikely great for planes, but more on the move, maritime definitely. And where we see remote places, we actually have some innovations with products that we can actually help for spectrum sharing. We want an ability to be able to reuse that spectrum. We're hoping that maybe the satellite operators will actually, you know, saying, okay, since I have the satellite in the sky already, offer that bandwidth for a lower price. And so we've come up with LNBs with switchable filters. So when you're actually close to, the 5G stations where you're actually operating, where your boat is coming close to land, going to port, you need to switch on your filters to make sure you don't get the interference. And then when you go out in open sea and you want to see all the channels out there, it's a voltage switching where you don't have to climb into the dish, and it switches the filters back out so that you can actually get the full C-band. You can actually do that with comms on the move as well. And you can actually do that with the remote sites where you go, you know what, I'm going to put the installation of this LNB in there. And when 5G comes in, then I switch it off. And then so you don't have to worry about the installation later in the future. So I think that's a good way for us to reuse the spectrum that's still out there with 5G, with 5G coming into C-band.
Okay, I think we'll try and speed it up a little bit. We got lots of questions coming in from the audience. So let me ask a couple more from the audience. Here's a big one from Mario. How do you see next generation non-geo satellites playing a role in the 5G ecosystem? Anyone?
I can start with that one too. I think, you know, geo has the problem latency. I see a lot of questions on latency as well too. And so, you know, when you geo, you're going to have that half a second delay, 500 millisecond delay, no matter where you are. It's just the way that, you know, the time it takes for a signal to travel up to the sky and then back down. With LEO, because it's not in the geostationary orbit, we will see that latency really go down in the future. So there's an opportunity for more voice applications and more things that are like time critical because there's less latency. So that's one of the key things we see.
I think if I can jump in on that one as well, I agree entirely with what Amy's saying. I think that there will become a critical element of the 5G rollout, but the big unknown on that is really where the gateways are going to be, and the size of the gateways that are required to access all of these non-geo satellites, and how the switching is going to be handled from there. You know, if you're looking at you know, connectivity back to, you know, or doing long distance calls, you know, is that going to be any better or any more efficient from you know, using a LEO? You know, not necessarily, depending on the route it's taking. But I think the orchestration in terms of how that signal processing is done and where those you know, where the voice is routed and to which nodes is really going to become more and more critical in terms of how the networks actually operate, and where they switch. So yes, they're going to be great, but they're going to add a whole degree of complexity above the current issues in terms of routing how the traffic goes into which gateways and how that gets to where it needs to get to.
And
Mike, your thoughts?
yeah, on my part, I mentioned at the beginning there that 4G had 4 catalysts, technologies that led to the success of 4G over satellite. And I think that when it comes to non-geo, it is one of those catalysts that are basically an essential component of the success of 5G. I sincerely believe that even 5G terrestrially connected radios can actually still benefit from having an overlay or a connection to a LEO type satellite for offloading of services. The whole magic of the SD-WAN is routable individual data streams, which you can pass along best path, be it over LEO or over GEO. Your SD-WAN capability allows you to pick a path for certain datas, which is really a changing, a complete change of any previous topology, because previous topologies were always hierarchical, always required a full backhaul. While now traffic can flow freely in any possible way. And I think that non-geo is really very much a real strong catalyst to allow for 5G to come to fruition as a satellite, over satellite, whether it's even simply backhaul over satellite. But in an SD-WAN environment, I think it'll be a killer app. I think it's one of those killer apps.
Yeah, I think it's just another tool in the arsenal, right? I think you're right, Mike. I don't think it's better or worse. I think it's just yet another solution that you can add to the mix in terms of the architecture. I think that's a good way to look at it.
Well, be a question of cost.
Another question about backhauling. You mentioned backhauling. So clearly there's going to be lots and lots of 5G stations deployed around the world. On every fence post, if you believe the hype. Do you see satellites acting as a backhaul to those local cell stations? Is there a business model for that? And how can we leverage the satellite unique characteristics? Mike, I know that's right up your background. So
yeah. There's a lot of work going on, and that's why I like when things like 5G come out, because it opens up the door for innovation. As I mentioned, innovation is everything. And I know that there's a lot of efforts going to pushing over-the-top services such as Netflix and YouTube's to caching servers that will be located closer to the edge in order to offload the main portion of the terrestrial networks. And for that, satellite is a fantastic medium. Okay, there's no doubt about that. Using multicast capacity, you can stream traffic and store it at remote caches for instant playback without burdening the network. These are all valuable things. And I think that, if anything, this pandemic has shown me is very interesting is that, when the schools shut down, okay, one of the critical parts of it was that there was no backup to the schools being shut down. Okay, there was no online education where the students can go to. And I see that, in the future, you may have every state in the United States or countries will have basic education already recorded. And your schooling could be a complement to that, but they could actually offload it off these caching servers. And this could be part of a requirement that the states will put forward in order to actually allow these kind of things. So there's so much stuff out there, and innovation is definitely the key. I went off on a tangent. I forgot what the question was. But
we're talking about backhaul, but connecting all these small sites. Maybe I'll throw it over to Scott from an operator perspective. I mean, like you said, it's expensive to lay fiber and connect everything, connect cell sites. Is there a business case for using satellites? And how do we optimize that both for the mobile network operators and the satellite operators? How do you see it?
Yeah, I think satellites can absolutely be critical to backhaul for the 5G networks. Especially around the sort of small cell deployments and out into the rural areas, because I think the bandwidth demands are not going to be anywhere near what they are on the main metros because of the density of users around those. You know, but that connectivity requirement from the user perspective, as I said earlier, you know, as we become more and more reliant on the applications and the handheld devices that we're using, that you're going to want those to work absolutely everywhere. Now, you know, you can't put fiber into every single 5G base station everywhere around the world. It's just absolutely not possible. The cost alone would, you know, be enormous, and that's where satellite really comes into its own. You know, and as I said earlier, with the bandwidth on demand capabilities, you know, you can keep those nodes in the network, and they can use very little capacity and have very, very low running costs, and until required. So, you know, when you start to actually incorporate that plus point into your 5G network rollout design, then the backhaul side of it is absolutely critical to have satellite involved. I will just say as well that I think Mike's absolutely right around, you know, as you get content and storage out towards the edge. I think we're actually going to see a bit of a reversal around how a lot of the big OTT content providers are running at the moment in terms of putting huge amounts of storage into data centers and seeing much more storage on the edge, because, you know, the cost of moving that video or media around, you know, is huge. Now, the closer you can put that to the consumer, actually the lower the cost is to that. So I think satellite, with its multicast and broadcast capabilities to be able to deploy that content to the edge, is also going to play a huge role in how we consume content and how the operators put that content to the edge nodes going forward.
Okay, I think you mentioned some key technologies there. So I have another question. We talk a lot about the network virtualization, software-defined networks in the mobile networking industry, cloud and edge computing, I guess, from the cloud industries. All kinds of investments, very large amounts of money being spent by the terrestrial R&D companies. So kind of two questions related to that for all of you. So where do you see satellite fitting within this complexity? And is there anything that satellite can or should adopt from the terrestrial world?
On my side, from the networking perspective, I definitely see that transparency to the terrestrial network is an essential component of people accepting it as part of their network rollout. For example, you mentioned network function virtualization and SD-WAN, getting back to SD-WAN. Basically enabling a system to tune so that real-time traffic, voice, and other critical traffics go on a terrestrial network. Streaming traffic can be directed over a higher delay link and other paths. Okay, and that higher delay link itself being a satellite connection. These are all important aspects. But in order to achieve and deliver upon that, okay, the satellite network has to become terrestrially friendly. Okay, going back to my first point, where proprietary solutions won't cut the bill anymore. It has to be part of an ecosystem. Okay, and that's where I mentioned satellite operators are going toward, satellite ground equipment vendors are going toward, where we have to be part of the same environment as a terrestrial network in order to be accepted moving forward 5, 6, 7 years.
Yeah, certainly the volumes are much higher in that world. And as standards evolve, and maybe there are things that we can leverage, as you say. Amy, how about you? I mean, in your world, are there things that you can adopt?
We're hoping, we're okay. This is looking really far out into the future. Just for a second, like if these cell phones in the future work in C-band, can't they be satellite phones as well too? So
why not?
So we're hoping that maybe one day that you can actually, your cell phones, if you're actually out of coverage, in the middle of nowhere, it goes into satellite phone mode and you can actually access the satellite. Maybe that's an option. I don't know how we're going to get there, but I think, as we evolve the technologies and we start sharing the spectrum, like Mike says, it's an ecosystem. You know, if it's all, everybody's working kind of unison to make sure there's connectivity for everyone, I think there's going to be more innovation, more solutions coming out where, you know, maybe, you know, this, like you say, software defined radios are going to come in so that you can actually redefine the way, the shape of your waveform so that now your cell phone is a satellite phone, hopefully.
Maybe. Scott, are you?
I'm raising my hand, Mauro.
Oh, sorry.
just,
Well,
just, to, just to show you the kind of innovation that I find super interesting is just on Monday, Nokia released, they released here a press release saying that as of the end of the month, they're putting out a 5G upgrade to all 4G radios. So by the end of 2021, they expect to convert all 5 million 4G radios that are deployed to 5G capable. And, you know, so when we look at satellite, we say, okay, you know, we don't expect to see rollouts of 5G over satellite until 2020 something, 2024 or 2025. But the reality is that these are innovations that are going to accelerate the deployment of 5G. Okay. Also, there's other innovation. There's what they call DSS, dynamic spectrum sharing. That's going to allow 5G to dip into the 4G spectrum and provide services from the 4G spectrum. Okay, so to give you extended range, because let's admit it, you can't cover rural areas with millimeter wave. Okay, so these are all serious innovations that are taking place by the Open RAN community, by the equipment vendors already existing, which are all geared toward accelerating the 5G. So it's going to come faster than we all believe. Regardless of the pandemic, it's going to still come out faster than we all believe.
Agree. Scott, from an operator perspective, service provider, what do you see that we can adopt from the terrestrial world, or maybe some of those other technologies I mentioned?
I think the biggest one that the satellite industry as a whole really has to adopt is open standard. I think we're far too proprietary on all of the equipment vendors using proprietary NMSs, proprietary traffic shaping, proprietary systems, proprietary hardware. You know, and we all obviously understand their reasoning for doing so and trying to protect their businesses. But you know, I think you have to take a longer term view at this and say, actually, this is going to happen. You know, whether you particularly want it to or not, take that jump now. Let's start to work or get an open standards group that works together to get the best solution. You know, and taking the bits from all of the different equipment manufacturers and vendors and the best of the technology and best of breed, and start to tie that in. You know, if you look at the terrestrial side, that's exactly what's happened. You know, whether you're using Cisco or Juniper, whether you're using Nokia, Samsung, or Apple, you know, the standards are the same. It works across all networks, and satellite's going to have to follow suit with that one, both in terms of being able to mass manufacture the terminal requirements in the volumes that are needed at the price points that are needed, as well as that ecosystem, as Mike was saying. You know, that's where us as a service provider have to be going. You know, it's got to be about what the end user is using from a service perspective, and not so much about how it is with delivering the connection to his device, because the consumer doesn't care. You know, they just want it to work. They want to know that they're opening the Outlook app on their phone and that it's tied through to the Microsoft 365 node in whichever data center that sits via whichever media it goes via, and that they can access their emails. Because I'm sure, you know, there'll be many people out there like me that travel the world with this industry, and you know, there's nothing more frustrating than suddenly one of the applications not working, and everything in this pandemic has pushed this is now moving more and more towards the handset and the remote working applications.
Sorry, I think we're running out of time. I think it sounds like a call to action from you, for sure, for the industry. Maybe just for the other guys, just to wrap it up, maybe what do you see as the challenges or steps that we should be taking as a satellite industry? Mike, Amy, any quick thoughts as we wrap this up?
Amy?
You know, I think, you know, it's, I think 5G is coming. I think there's going to be a big hurdle in making sure that there's coordination to make sure terminals are getting upgraded quickly. I think we need to find a way to make sure we're working to go together to go at the same goal of helping this 5G rollout. I think there's going to be benefits on both sides. A lot of changes in our industry, and just looking to see that we can complete this role in a most quickly, and most efficiently.
Very good.
And to mirror what Scott was saying, perhaps his call to action, but I strongly believe that there will be a very strong move toward these open satellite network. Okay, let's call it that. I strongly believe that, and there'll always be a need for some proprietary solutions. As Scott mentioned, there's micro satellites and all these other things, which you could probably deal with at best in a proprietary manner. But overall, I do believe that the satellite industry, as a whole, is going to learn a big lesson through this 5G evolution, and they will adapt to what is required, or they won't achieve the success that they hope for.
Sounds exciting and challenging, but also I think certainly lots of opportunities from what I'm hearing you say. So again, I want to thank you for your contributions, for having such an interesting conversation. I want to thank the audience for their time and joining us. If you have submitted questions and we didn't answer them, they will all be answered in writing on the GVF website. So keep the questions coming even after the webinar is finished. And we will also post a video of the session on the GVF website. So again, thanks to everyone. A quick reminder for the next GVF webinar, which is on the 30th of July, ground segment transformational antennas. So please register and sign up for that one. And again, thanks to everyone for participation and for a great and interesting conversation.